You get spaghetti code when you have code that has a complex or tangled control structure. Historically, this came about through undisciplined use of goto statements and other unstructured coding practices. With modern structured programming languages, crazy goto structures are less common, but you can still get spaghetti code easily enough if you aren't careful. Typical anti-pattern signs that you have spaghetti code include the following: deeply nested conditional statements, for example, if-else structures nested 4 or 5 or more levels deep. Modules that have switch statements nested inside or outside of all but the very simplest if statements. Or any code in general that has high cyclomatic complexity, which involves code that has too many paths to perform effective unit testing. We'll talk more about cyclomatic complexity on the next slide. This topic is important because complex code tends to be buggy code. At a first level, it is well known that unstructured code tends to be buggy code. This is because unstructured code is generally hard to understand, difficult to test, and very difficult to peer review effectively. But even structured code can be just as hard to understand, test, and review if it is too complex. The general idea of avoiding spaghetti code is to limit the complexity within each unit of code, such as a subroutine or method. At some point, the complexity has to show up somewhere in the software, but the idea is to create moderately simple modules that you can understand in isolation, test in isolation, and then, when you're confident of the quality of each module, put them together to create a system. You may have seen at some point a subroutine that is 1,000 lines long or more with hundreds of if statements. That's usually spaghetti code. The question is, how complex is too complex, and how do you know when your code changes from good code to spaghetti code? The motivation for limiting complexity is twofold. First, complex code is difficult to review. If your code is too complex, you'll miss defects when performing peer reviews. The human mind of a peer reviewer can handle only so much complexity before it compromises your ability to find bugs. The second motivation to reduce complexity is that complex code can be difficult or impossible to test. If you have extremely complex code, there may be no practical way to reach each line of code with a set of unit tests, leaving untested code.